All right, let's look at the topic finding mole ratios from chemical formulae or formulas. All right, so I pulled up a sample problem here and I've screenshotted it and put it over my whiteboard. So I'm going to be flipping for this problem. I'm going to be flipping back and forth. Watch this. Between my whiteboard, no, not that. Just a second here. My whiteboard and and ALEKS. Okay, so let's go over to the whiteboard. And let's have a look at this. Finding mole ratios from chemical formulae or formulas. This is the chemical formula for talc, all right, which is such and such. Lots of atoms in it. And here's the question. An analytical chemist was determined or has determined by measurements that there's 20 moles of magnesium in it. How many moles of hydrogen are in the sample? Okay, so really this depends on your knowledge of what is meant by these symbols, right? So here's magnesium, and that 3 right there, maybe everybody looking at this video knows that means that there's 3 atoms of magnesium in one big molecule of this stuff, if we can think of it like a molecule. And it looks like there's 2 of these things in it. Each of them have 5 oxygen atoms in it. So there'd be 10 oxygen atoms in it, and there's 2 hydroxides in it. So just lots of atoms, okay? So what I'm going to do is I'm going to come over here. I'm going to say magnesium. I'm going to make a list. Magnesium, silicon, oxygen, and hydrogen. Okay, and then I'll do ratios later. I'm going to go the long way first. I admit that. All right, so let me get rid of some of this over here. Oh, man. There you go. Okay. So it looks like, first of all, we've got 3 this is the only place magnesium shows up, so there's 3 of those for every unit of this stuff, talc, right? It looks like there's 2 silicons, but wait, there's 2 of this whole thing right there, so it looks like it's 2 times 2. There's 4 silicon atoms for every mole of this stuff, right? And for oxygen, it looks like there's, again, 2 of these, whatever you want to call that. There's 2 of them. And there's 5 each, so that's 10 right there. Looks like there's 12 oxygen atoms in there. And hydrogen, looks like there's only 2. Okay, so what I'm going to be asked to do then is to set up a ratio between magnesium, and moles of hydrogen. All right, not a big deal. What I'm going to do is I'm going to say moles of hydrogen. Right? What I want to know, and I'm given moles of magnesium. All right, no big deal. So it looks like I'm given 21 moles of magnesium, and I want to convert this to moles of hydrogen. Okay, I can see what I'm going to do now. I'm going to I got to put moles, I'm going to do my molar ratio here. And I'm going to put moles of magnesium here so that these things cancel, right? And moles of hydrogen on top so they don't cancel, right? There's my moles of hydrogen, moles of I want that, and I don't want that. All right. So I just come over here then, I guess. Okay, I get it now. I'm going to come over here and I'm going to say there's 3 moles of magnesium for every 2 moles of hydrogen. Okay. 3 moles of magnesium for every 2 moles of hydrogen. There's my 2 moles of hydrogen, and I'm done. Now, I need to do the math on it, right? So 21 divided by 3 times 2. 21 divided by 3 is 7 times 2 is going to be 14. All right, so 21 divided by 2. Let's just do it in the calculator. 21 times 2 divided by 3 equals 14. Just what we thought. All right, so it's 14. Put a point there because that's the sig figs. And let's check it and get some green. Okay, so hopefully that's helpful. Back as a quick review, what we did was I went over here. Where's my whiteboard? I went over here and found out first of all, I found out the moles of each thing in the overall chemical formula. And then I went over here and said, what's the mole I was given? Right? And then I had to set up my conversion factor. Convert. crossed stuff off, made sure I had what I wanted in the end, which I did, and then I did my math. Okay, hope that's helpful. Good luck.